Okay, can we start? Hi friends!
Hello!
My name is Konstantin, I'm from Russian Federation, and I have a talk about Perl6 and blockchain. The things connected with some. I had to connect the things together, and now I present how I did it. On the slide you see infographics of my talk, because there are many different things in it, and I will try to speak short about any of it, some of them. First of all, I should say that I have an experience for years in content management system development. It's as you know, like a Perl mongers, any of us worked with web, work with simple CGI scripts, work with web panels, develop those panels. So I will not speak more about it. I have my own CMS. I have it was driven about about 30 sites. It's Russian resources from simple web pages, landing pages. There are web stores, stores that selling electronics, selling products, no matter. And maybe in 2012, I decided I was involved in Perl6 life. I installed Perl on my laptop. There was a Perl virtual machine at the time, and I think it's great to port my Perl5 CMS to Perl6. About maybe 2, maybe 3 weeks work, I understand that there are no enough modules, because at that time Perl6 was very small. Community ecosystem was small and not how it is now. So the work was closed on Perl6, and I developed my own CMS in Perl5. And a year ago, I started Perl6 development again. I tried to implement the features of my CMS on Perl6, and at the time, I was involved in blockchain development. I have a few projects on blockchain, but it's not cryptocurrencies project. It's like a blockchain technologies in documents. We store documents in blockchain and other. Okay, what is CMS? As a, you know, I don't stop on the slide more. It's important to say that we have 5 features that we should have on our CMS. First of all, it should be 2 layers of access. I mean, presentation layer that users see, and administration layer where you could change something, wrote a new content, and other. Of course, CMS should based on templates. Okay, you need a new design. You don't do any programming. You download template, and your site has a new look. Of course, scalability, modules and others. Editing tools, what you see is what you get. And access roles, access levels. Okay, it's basic things. It was 20 years ago. It was 10 years ago. They're not changed. It's a basis. Here is a small workout what content management systems are in Perl6. Of course, maybe I forget something, but short Google, give user, maybe you know this project, is static generation, static page generator with built-in server. Okay, cantilever. I think this project is closed now, but maybe it's not true. Don't say. Okay, November is Its wiki engine wrote many years ago. It's the first wiki engine in Perl6. As I know, today there is that site with simple content. Okay, it's the oldest one, I think. And that CRO is a framework, as we hear yesterday. There are web services built in CRO, and I think if you use CRO framework, you could create your own CMS without any problems. And Bailador, that's interesting project. This project is in active development phase. Commits on GitHub. So if you're interested, I advise you to check it. From this list, I install it and use Yuzu, first CMS, and have November, of course, because as I say, in early 2012, when the period when I was dealing with Perl, only November was. November maybe in 2015. No, it's also one. And I had a small experience with CRO. Okay, why we need blockchain? And what is the main feature of blockchain? Okay, blockchain is a hyping. We say in Russia hype. Yeah, there is much hype among blockchain stories, among cryptocurrencies, but we should mention that there are two basic features of blockchain. First of all, it's a security. Data on a node, on blockchain node, data in blockchain network is highly secured. It's ciphered by security algorithms. We have public and private keys, so it's main feature. You don't think about security at all. Also, and the next feature is that blockchain data is decentralized. We have any node where all data is concentrated. Any node could send a part of data and could, if one node is broken, others will work without that node. So if the network has such decentralization, we could speak about the data security, data reliability. And others, cost reduction, cloud computing. I think the main features too: security and decentralization. This slide, I think I told these features, and I have to talk about restrictions. There are a few blockchain approaches. First, blockchain like a Bitcoin. It's a canonical blockchain without smart contracts. What is smart contracts? Smart contracts is a program inside blockchain we could exec. We could exec it with a code. So smart contract will provide any other functionality that there is no on a basic blockchain. So you could write your own code, integrate it into blockchain. It will be a few slides how to do it. And then you could you achieve address of your smart contract, and then you execute, run it with your own code. And there are nowadays three more popular blockchain blockchains. It's Ethereum, Hyperledger, and Telegram. No, Ton, I mean. So restriction is that if you want to use smart contract, you should use these ones. Yeah.
One of the features of Bitcoin and most other cryptocurrencies is that you need a lot of computing power to add something.
Yeah.
I assume that's not the case for the CMS.
Okay, I will speak. Yes, it's a good question. We will see it.
Okay.
Why we need decentralization in CMS application? First of all, it's simple to have layers, presentation layer or administration layer on physical nodes, on each layer on each physical node. What do you mean? What I mean? If you have, for example, WordPress, you have a web server, and people come to your domain, look what your site is, read content and other. And in this way, the administrator also have web panel on that server. So if you have a logs, you see that the hackers pushed requests to a server, tried to brute force password and something else. Because the administration layer and presentation layer are on one server. When you use blockchain, you could have presentation layer on a public server and administration layer on a private server or private netbook. For example, I have a node on my laptop, so I could change something on a site from the laptop, and it will be sometime later changes on a public server. Of course, the second thing is data is secured. So if you have a site with something you need to secure, you don't think about how to cipher, how to create the security layer. And the third thing that we have built in between access rights and rolled in blockchain. So we don't need any authorization system. We don't need to any things like database with the roles, with the passwords, with something else. Also is encapsulated in blockchain as is. Now I will speak about your question. Of course, there are few algorithms of blockchain data mining. First, as you know, it's a proof of work algorithm. So when something happened in blockchain, when transaction comes, nodes running, nodes counting hashes, the electricity gone to the ASICs, but the main goal of this algorithm that is a hard task to find out the hash of transaction, and you need a powerful laptop server or something else to achieve to find out the correct hash. It's the first algorithm. The next, and in this algorithm, if you have very powerful computer, you will get much cryptocurrency, or you will get much correct hashes. The next algorithm is proof of stake. In this algorithm, we have the next idea. If you have more balance, cryptocurrency on balance, you have more power to get decision on blockchain network. So maybe in other words, if you can pay, you pay, you got it. If you have no any balance, for example, this algorithm includes also integrated also in Ethereum. You have no, if you have no any cryptocurrency, you can make decision on this chain. But I use here in my talk, I will speak about proof of authority network. It's algorithm where in network we should delegate some rights, delegate authorities to nodes, and only these nodes could accept transaction, could write transaction in blockchain. So we don't need work, we don't need balances. We configure our network such that the node A, B, or D can write to blockchain. And when they make a consensus to each other, they write the transaction. So it's this approach is used in private banking, in private financial things, and private something other where the algorithm is. So parity Ethereum, it's a client that provides proof of authority functionality. And the next thing, we need to create a smart contract which could help us to store data on this blockchain. That's a few words about proof of authority network. I say before that doesn't depend on not solving arbitrarily difficult mathematical problems and not especially blocks. Okay, that's past. Okay, the next thing is that we should store data in blockchain. I don't say that we should store anything in our CMS, but we should store maybe something 10% data. What I mean, what I'm talking about. Maybe you have a voting system on your website, maybe you have ratings, maybe you have special education program on your site. So there is a problem when someone could make its reputation, make it rating high. For example, there are the things that any people create many accounts, many different logins, and increase their specific increase their ratings or their karmas, how to say. So we need to store in blockchain some sentences for tempered data. And for this, we need a smart contract that implement basic database features. It should make functionality for creating, reading, updating, and deleting data. So in this smart contract, we need 6 methods at least. Maybe more, but at least one. Okay, that slide's about CMS. Okay, that's something about architecture. I should say that we have a headless. Now I have a headless structure. It means that, for example, on laptop we have a front end. Maybe we use a web server on node which provide presentation layer, but the main approach to have a front end on each device. That's not correct on the slide that we have connected to blockchain watches, TV pool, so maybe glasses. It means that we have any devices where we could start a blockchain client, and it have a functionality to the network, to access the network. Strengths and okay. We have any question? more. Let's speak about the routing. Yesterday, John have a presentation about Mojo, and there he say about roads, how the roads are in the system. He spoke about in our CMS. There are specific module. It's was ported from Perl 5. That's module calling router write. You could find it on GitHub. There are a few routers for Perl 5 applications, and after a small googling, I found that that module router write is okay. I like it because it has some functionality that is okay. There it could create regexes in roads. It could we could use some different variables in roads, so it has a rich functionality for routing. And I ported it maybe a few weeks. It's work, and if you're interested in routing in URL or routing in Perl6, you could check it out. It's well documented. I wrote a full doc on repository where this router hosting. So okay, our CMS is headless. The main part we should speak about now. It's headless. It's use specific router in it. It has there's dependencies. I tried to create a very short list. Try to stand on original Perl6, not Perl6, original Rakuda distribution. As I know, JSON Tini also included in Rakuda Star. So it's six external moduli. I think it's great dependencies because we don't need to install anything else. Okay, it's light with Perl6 and Ethereum. A small how-to about. Okay. How to connect Perl6 distributed decentralized application with Ethereum. First of all, we have the same pyramid. On the top level, there is a Perl application. I mean, content management system. The next level is a net Ethereum module that provides applicable programmable interface to Parity client. Parity client is a daemon. Maybe okay, it's run like a daemon on host, and it provides like a microservice. It has RPC interface, and we can send REST requests and got answers from here, from its server. To communicate with Perl application with Parity client, we should have net Ethereum module, also ported from Perl5, and there are a few additions because net Ethereum Perl5 project was deprecated, was closed, no support yet. And when I ported this module from Perl5, I found a few errors, fixed them, and try to implement something new. For example, when we speak about RPC client, we should keep in mind that the request, the type of RPC request, types of RPC requests from day to day. There are some requests are deprecated, some requests integrated for new in this client. So we have keep a hand on pulse to provide this functionality in NetEthereum. And on the bottom level, there is a blockchain data, and we don't know. We needn't to know how it works because Parity client, its blockchain client, operate with this. So the main thing, we have application on Perl6 that use specific API from NetEthereum and then data stored in blockchain. But on these levels, we have a smart contract that I spoke about a few slides ago. Oh, it's about NetEthereum. There are links for this. It's important to mention that there are a few Ethereum clients, and this model provide interface to them all. Get, it's an official Ethereum client, and Parity is a client with a proof of authority algorithms. Then we should speak about the thing that when we store data, okay, in CMS, in content, we have a text. And if we need to store text in blockchain, we should think about that if our page had a weight like maybe 1 megabyte or more, it will be not good to store this megabyte in chain, because to provide storing, client taking costs of transaction estimated in gas. Gas is the internal value of this implementation. So the approach is to compress data before pushing it to blockchain. In NetEthereum was Lempel-Ziff-Welch algorithm implemented. It's opened and has no problems to implement it. And compression is about 30%, 50%. Every data, maybe you push megabyte, you got 500 kilobytes on the other hand. So, but megabyte for test it's a weight, it's heavy page. Usually it has maybe 50 kilobytes, maybe 20 kilobytes, and compression is good for this amount. And also should say about that in private networks we have unlimited gas. We don't need to think how to pay for transaction. We have unlimited account and gas, it's not a problem. But when you have heavy content to store blockchain, the problem is a speed. On these heavy pages, transactions may mind 1 second, 5 seconds, but when you compress it, transactions mind immediately. And to increase speed, we use specific well-known techniques to boost our application. Because in whole, I think that when I use with Perl6 like a web backend, I found out that it's such slow. Maybe I don't have do any optimization. Maybe I incorrect programming. Maybe something else. But using a traditional CGI interface where script, Apache, Nginx, and user, that the chain is such slow. But we have a solutions. First of all, it's a caching tools. For Perl6, there are modules for communicating with memcached. I use Redis to communicate with Redis service. So it's good when we achieve data from blockchain. For example, we don't need to take data from blockchain if it synchronized with cache. We take data from cache, but when we push data into blockchain, we update the cache on the same step. Of course, async write, I mean that we don't need to wait while transaction will be mined on node. We pull transaction, we pull data, get transaction hash, and then go to our work. In front end, we have a agent with callback that tests the result of transaction. If it mined, we have pop-up. If it's not mined, okay, we have an error in our web panel. And the last thing is the lazy loading. I mean, the approach is to store data in blockchain in buffers. I mean, if you need 100 kilobytes of data to store in blockchain, you divide it to frames, buffers, as I say, and store 25 buffers by 4 kilobytes. It's that's such approach, because when we have to preview data, we don't need to take all it from blockchain. We take a head, and if you want to get it all, you press more, and on the other hand, data will be achieved. Also, frames is frames is important thing when you need to implement progress bar on front end, because we don't have any. We could not take the information from blockchain client how much data is pushed. So when we pushed frames, we update our progress bar. But as I say, at the start, if we push all data to blockchain, the application is very, very slow. Not slowly like one request for 1 hour, but touch slow. And then and the approach is to think, what data should I store in blockchain? What data should I store in regular database? Maybe in flat file database or something else. And in our CMS, we have a layer, data storing layer, where we could mark this table will store in regular database. This table we store in blockchain, and this table we storing in flat files. Okay, regular databases we work with every day, and there is a very impressive Perl6-based model with. As I subscribe to GitHub, and almost every week, I think every week there are push requests, and their development process for this model, it's great. And we could store something in regular database using Debish on our data storing level. For this data, we have a function to pull it. For example, I use it with Postgres. Yeah. Okay, in regular database we store 10% intensive data, temporary data, cache, maybe something else which don't need to store in blockchain. Also in the flat files. Flat file is good for example, I have I have a few servers where there are no database by the tariff. If you need database, you should pay more money. But for example, for 50 cents for a month, you got only file system on the web server and without email, very low resources servers. And on this server, I run this CMS with flat file database. I also simply push data into files. And this also accepted on data storage level. And the last thing is the data for blockchain. As I say, votes, ratings, exams, marks, maybe documents, maybe content which should be protected by timestamps. Okay, it's something like a roadmap. I started on last December and think to create full functionality with layers, with administration layers. Now we have just a presentation level and blockchain support at the final stage. Okay, that's all. I think you understand something from my talk. Okay,
One question on the nodes in your data. If the
nodes, it's site driven by Perl6 and blockchain. It has home link. This presentation, it's taken from blockchain now. It's stored in blockchain. I presented you online from a blockchain. And this is the speeds. Okay, it's it's quite slow. We have a feedback. Donate. Okay. Okay. Well, render time about 2 seconds. It's Perl6, blockchain, transaction waiting, and get content, push content to the user. About 2 seconds. I think it could be optimized. It could be maybe if too deep with a deep thinking, something could be optimizing. But I think on the next step. Okay. Thank you.
Just a quick question. When it's out on the blockchain, maybe it's just my ignorance of blockchain. If one of those nodes goes down and you have data on the node, is your data lost or is it?
No. Oh, okay. As I say, when you use private network, you delegate rights to, for example, 3 nodes. Okay. When one node down, that node should be provide all data. But when the 2 nodes from 3 nodes lay down, okay, data still will be on that authority node, and in all nodes on network. But this authority node cannot cannot push new data to a blockchain.
But the data is duplicated. Yes, I just wanted to replicate it.
Yes. On each node have all ledger, all data is all on each node. When you push data, authority nodes
will push it out for you.
Get consensus.
But there's a time limit.
Yes. They say, okay, this is a new data, push in the chain, and push on other nodes. But also you could be in a mode when you don't get data from authorities. You should tell them, give me a new data. It's a light mode because data may be gigabytes, thousands of gigabytes, and you could take the last data. Now I have a network, this node on this laptop, node on Germany web hosting, and node on my job in Moscow. 3 node networks and 2 authorities. It's my laptop and my node at my network because they are secured. I think when I close the laptop, okay, nothing will be happen because only one node, authority node exists and no one will push new data. That means that if the site will be hacked, maybe by something, data in blockchain will be secured in this way.
So does it, if you do push data when one node is down or 2 nodes are down, you just stay there until it gets up?
Only your.
So it doesn't get pushed out.
Yes. But when the node tries up, data will be pushed to them. Yeah.
Unclear on concept.
This also means that all the data, all the information you put on your CMS will only add to the blockchain and never be deleted.
Yes. It's a feature. It's the next feature that we have a full story of modification.
But you've got unlimited backup.
Yeah.
Which is a good thing in one view, but if you have say a news site with lots of articles posted
Yes.
that are irrelevant
Yes.
a year from now,
Yes.
it will just fill up.
Yes. That's
The use case is very.
yes. That's why I
well-defined.
speak about compression. That's why I speak about the nodes with big hard drives. That's why I speak about that you should think about data in blockchain and data in regular databases.